the previous session, we applied the kinematics equations of uniformly accelerated motion in various situations. Now, we continue our discussion with the concept of relative velocity. Relative velocity is velocity of one object with respect to the another object, or we can say the velocity of one body with respect to another body is called relative velocity. To understand the concept of relative velocity, let us consider a situation in which, let us say, you are travelling in a train A. Let us say this is train A and the another train B is moving in the same direction in which train A is moving. Suppose the velocity of train A is VA and the velocity of train B is VB, with VB greater than VA, so that it may overtake train A. Now, during the time when train B, which is moving faster than train A in which you are sitting, will overtake train A, then the speed or the velocity of train B may appear slow than its actual speed to you where you are sitting in train A. But the same train B will appear to be moving with the actual speed to the observer who is somewhere standing on the ground. Similarly, if suppose the trains are moving in the opposite direction and suppose again here VA be the velocity of train A, VB is the velocity of train B. Now, when this train A will overtake the train B, then the person who is sitting in this train A, suppose, to him the velocity of train B will appear to be faster than its actual velocity, that is VB. Whereas, to the observer who is standing on the ground, to him the velocity will be the actual velocity. He will observe the actual velocity with which this train B is moving. And that is how we talk about the relative velocity. Again, I consider another situation. Here, let us consider two buses A and B. Suppose this is bus A and this red color bus is bus B. They are moving uniformly with average velocities of VA and VB in one dimension along the positive x-axis. Suppose initially at time 0, the position of bus A is XA and the position of bus B is XB. Now, after time t, suppose these buses are at the locations of, are at the positions XA dash and XB dash. So, we can find out, we can write down the equations for the position of this two buses A and B after time t. Accordingly, we can say the position of bus A is XA dash, which is equal to the position XA, which is at time 0, plus the displacement or the distance travel in time t. So, suppose this is the distance travel. Now, how to calculate this distance? As we know, the velocity of bus A is VA. So, in time t, it travels a distance of VA into t. So, now the position of bus A after time t can be represented as XA dash is equal to XA, that is the original position, plus the distance travelled in time t, that is VAT. Now, let it be equation 1. Similarly, we can write down the equation for the position of bus B in time t. So, that is XB dash can be written as XB, which was the position at time 0, plus the distance travelled in time t, that is VB times of t. Now, let it be equation 2. So, these two equations represents the position of bus A and B after time t respectively. Now, let us find out what will be the position of bus B relative to A. Now, As seen from bus A, the displacement of bus B can be calculated by finding xb dash minus xa dash. That is equation 2 minus equation 1, which can be written as xb dash xa dash. So, if we subtract equation 2 from 1, we obtain xb dash minus xa dash equals to, now we can write as xb minus xa plus vb minus va into t, right. So, here in this equation, this vb minus va can be considered as the velocity of B relative to A, or which can be written as VBA, where VBA is VB minus VA. So, here VBA is the velocity of object B relative to object A, which is equal to VB minus VA, that is the difference of the two velocities. Similarly, VAB, that is velocity of A relative to B, is written as VA minus VB, that is the difference in the two velocities again. This is how we find the relative velocity. Now, let us consider a bus is moving with a uniform velocity v. Here you can see this is a bus and there are two persons A and B sitting in this bus, and let us say this bus is moving with a uniform velocity v towards right, and a person is standing, C is standing on the ground. So, you can see here is a person who is standing on the ground. Since the bus is moving with a velocity v, so we can consider that both the passengers A and B which are sitting inside the bus, they are moving with the same velocity. So, we can write down that VA and VB both are equal to V, whereas the velocity of C, that is VC, is equal to 0, because this is the velocity of the person who is standing on the ground. Now, suppose we need to find out the velocity of B relative to A. Since they both are having the same velocity, so VB minus VA, that is the relative velocity, the velocity of B relative to velocity of A will be equal to VB minus VA, which is equal to V minus V, since both are moving in the same bus, both are sitting in the same bus. So, that is why they both are moving with the same velocity, that of the bus. So, that is why the velocity of B relative to A is 0, and that is what we say, that both the person who are sitting inside the bus, to them they both are at rest with respect to each other. Similarly, the velocity of A relative to passenger B is again VAB, which can be written as VA minus VB. Again, since both are moving with the same velocity, the relative velocity will be 0. Now, the velocity of A relative to C, C is the passenger who is standing on the ground, C is the person who is standing on the ground. So, the velocity of A relative to C or the velocity of B relative to C will be same, that is V minus 0. So, that is how it is equal to V. So, the velocity, since the ground is at rest, we consider ground to be the reference frame which we consider to be at rest. So, that is why any object or any person who is on the ground is considered to be at rest, and that is how the velocity of that person is considered to be 0. So, here the velocity of A and B, the velocity of passenger A and B or that of bus will be equal to the velocity V relative to the passenger C. Now, let us consider the same situation graphically, wherein we will try to plot the motion of these two passengers A and B who are moving in the same bus with a velocity V. So, if we plot a position time graph, so this kind of pattern will be obtained. So, let us analyze this xt graph. So, here we see that the relative velocity of A with respect to B or the velocity of B relative to A both are 0. We also know that the slope of xt graph gives the velocity of that particular object. Here the slope will be same for both the moving objects A and B, and that is how we see that both the lines are parallel to each other. Since the slope has to be same because the relative velocity is 0, there which is only possible when the velocity is same for both the moving objects. So, in this situation we get the two lines parallel to each other, and that is how we plot a position time graph for the two objects which are moving with the same velocity. So, here can we consider the situation that the two bus or the two cyclists, they are moving just with the same velocity parallel to each other? Yes, we can plot the same graph for these particular situations. Now, let us consider the another such situation wherein let us say initially the objects are at different position. They may be at the same position or they may be at the different positions. So, in this situation we consider that the two objects A and B, they are moving with different velocities with VA greater than VB. Initially the two objects may be at the same position or may be at the different positions. So, here in this situation we consider, let us say object A is at this position, maybe at a mark of 10 meter from the origin, and object B as a 40 meter mark from the origin initially. Now, since VA is greater than VB, then VB minus VA is negative and VA minus VB will be positive, right. So, since VA is greater than VB, we may conclude that the slope of VA will be more. The slope of xt graph for object A will be greater than the slope of xt graph for object B, and that is how we can see here that the slope is steeper for A. The slope of graph for object A is steeper for A, and at this point of intersection both the objects will be meeting at this particular instant. So, in this situation we can see that at 3 seconds, at an instant of 3 seconds, both the objects will meet. Now, the another situation I consider wherein suppose VA and VB are of opposite signs. That is, we can say, let us say VA, object A is moving towards right and object B is moving with some uniform velocity towards left. Initially, let us say the positions are suppose this is let us say 10 meter from the origin for object A, and again plus 40 meters from origin for object B. Now, since VA is in the positive direction, that is object A is moving in the positive direction, that is why the slope will be positive, that is represented by a line of blue color. So, that is a slope for object A. on XT graph. But since B is moving in the negative direction, therefore, its slope will also be negative. Again, the point of intersection represents the instant where the two objects will meet. So, here we see at a time of 1 second, both the objects will meet each other. So, this is how we can represent the relative motion. This is how we can represent the relative motion between the two objects graphically. Now, let us consider a numerical based on the concept of relative velocity. Consider two parallel rail tracks run north to south. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. Suppose we consider this direction to be north and this direction to be south. So, we consider, let us say, north direction to be positive, then obviously the south direction will be considered as negative. Now, here train A moves north with a speed of 54 km per hour. So, we can say that the velocity of train A is equal to plus 54 kilometers per hour. And if we convert it into meter per second, it comes to be plus 15 meter per second. Similarly, velocity of train B, since it is moving towards south, so its velocity will be taken with a negative sign, minus 90 kilometers per hour, which is equal to minus of 25 meter per second. Now, let us say what we need to find out. In the first part, we need to find velocity of B with respect to A, that is velocity of B relative to velocity of A. So, we know that velocity of B relative to A, velocity of B relative to A is VB minus VA. So, VB is minus of 25 minus the value of VA is plus of 15. So, on solving this, we get the answer as minus of 40 meter per second. So, how do we interpret this result? Since the relative velocity, the velocity of B relative to A is minus 40 meter per second, it means that the velocity of B relative to A is 40 meters per second from north to south, that is towards south. Now, velocity of ground with respect to B. So, we know the velocity of ground is considered to be 0. So, here we need to find out VGB, that is Vg velocity of ground minus velocity of train B. Since the velocity of ground is 0 minus velocity of train B is minus of 25. So, on solving we get it equal to 25 meter per second, and that is what our experience is also. Suppose we are travelling in a train, then it appears to us that the ground is moving in the opposite direction of our motion. So, similarly, if any passenger is sitting in train B, then to him, he is moving towards south direction, but to him the ground will appear to move towards north. So, that is positive 25 meter per second and with the same speed. Now, in this third part, we need to find out the velocity of the monkey who is running on the roof of train A against its motion, and what is given is the velocity of monkey relative to train A is given to be minus of 18 kilometers per hour. Since as seen by a man standing on the ground, the monkey is moving towards south. So, which will be equal to minus of 5 meter per second. To calculate the velocity of monkey, we can write the equation Vma is equal to Vm minus Va, or Vm will be equal to then Vma plus Va. Now, substituting the value, we get minus 5 plus the value of Va is 15 plus 15. So, on solving we get it equal to plus 10 meter per second. So, that is how we can conclude that the velocity of monkey is 10 meter per second towards north. Now, let us revise what we have learned today. The velocity of one body with respect to another body is called relative velocity. The velocity of object A relative to object B is expressed as VAB, which is equal to VA minus VB. Similarly, velocity of object B relative to object A is represented as VB minus VA, or we can say VBA is equal to VB minus VA.